All right, so we're going to start out by looking at solving inequalities again, but this time we're going to look at inequalities that have higher powers. Okay? Maybe an inequality that's like an exponent of 2 or 3, right? Instead of just an exponent of 1. So this is a formula I think we looked at before for projectile motion. We're going to use the same formula again. The only difference today is instead of having an equal sign right here, you're going to have an inequality symbol. Either less than, greater than, less than or equal to, greater than or equal to. But just a reminder about what everything stands for. V sub 0 is the initial speed or velocity. S sub 0 is the initial height. T is always measured in seconds. And then S is the height of the object in feet. So it's basically telling you how high an object is going to go based on how fast it was thrown and how many seconds have gone by since you released the object. Okay, and we're going to focus mainly on using a graphing calculator in this section. They do mention something about what's called a sign pattern. So if you see the directions in the homework that say use a sign pattern, I think we're just going to stick with the calculator. Okay, so this one says that a ball is thrown straight up from ground level with an initial speed of 80 feet per second. Okay, so first thing we want to do is fill everything that we have into that formula. So we want to write a formula that represents the height of an object that's starting on the ground and it's being thrown upward at 80 feet per second. Okay. So when we write the formula, it always starts out with S equals, and then what's the first thing that comes after the equal sign in the formula for the height? This part never changes. Yeah?
Negative 16.
Negative 16, and what's next to that?
T squared.
T squared. Okay, that doesn't change. Okay, the next part is going to change. Plus V sub 0 t. What's our V sub 0 in this case? Yeah?
Initial velocity.
How much is it?
80 feet per second.
80 feet per second. So you're going to fill 80 in for V sub 0. And what's next to 80?
T.
T. And the last thing you have to do is plus the initial height. What was the initial height of the ball? Yeah?
0.
0. It was on the ground. So that's the formula that represents the height of this object based on those conditions. Now, they want to know when the ball is at least 64 feet above the ground. What does at least mean? Yeah? Right, at least translates to a greater than or equal to symbol. So if I say that you have to have at least a 70 or higher to pass the test or something. Right? At least means you need a 70 or greater number. Okay? Can include the number or higher. Okay, so let's graph. Let's figure out what we're going to graph. We want the height of our object to be 64 feet or above. That's what we need to graph. And the height is given by that formula. This is the height. So we're calling the height S. Now fill in the formula that we have for S. Negative 16 t squared plus 80 t. So what we'll do now is we'll graph the left side in y1, we'll graph the right side in y2, and then we'll see where they cross. So negative 16x squared plus 80x and 64. Now, x is my time. What's the smallest amount of time that could go by in this experiment? Yeah?
1 second.
We could have less than 1 second. You could look at how high it is after 0.6 of a second. Yep.
0.
0. Okay, we can't have negative time. Also, what's the minimum height that the ball could have? Yep.
0.
0. We're not talking about underground, it's staying above ground. The max height is how high it's going to go. We don't know that. We could just try 110 feet. And if it goes higher than 110, we'll adjust our graph to go higher. Adjust our window. Okay, so there's the height of the object. And now we're going to have a line at 64. And they want to know when the height is 64 or higher. So what part of that graph are we interested in? Anything what? Above or equal to, right? Anything above or equal to 64. So that would be the top section of the parabola. From here to here. So we have to figure out when those x values occur. Right? So if you think of it, putting a line in here, right about there, we're going to calculate where that is on the x-axis, but it looks like it's at about what number? Looks like it's at about 1. And then we need to use calculate, and we're going to figure out where that one is. But that x value looks like it's at about what? 4. Okay, so I think it is going to be 1 and 4, but let's just double check. Second calc, intersect. Okay, if I just hit enter 3 times, it'll give me one of them randomly, wherever my cursor is. So I get 4. That's the second one. And if I did intersect again, I would get 1. That's the first one. Okay, so we got our intersect. So when is this object above 64 feet? Between what times?
1 and 4 seconds.
Right, between 1 and 4 seconds. So we could say the time is greater than or equal to 1 second. But it also has to be less than or equal to 4. If you go before 1 second, it's still on its way up. If you go after 4 seconds, it's already back down under 64 feet. Okay, so any question on using the graphing calculator to figure that out? Yes?
When I typed it in mine, it came up with not that.
And did you type in the same thing?
Yeah, I typed in the not. That's why I'm confused, because
You forgot your x on the 60. Okay. So next one, okay, still related to the same problem. How long does the ball stay in the air? Okay. Excuse me. What do we know about the ball if it's in the air? Yeah?
Its height would be greater than 0.
Its height is above 0. So now you're basically doing the exact same problem again, except instead of looking at when the height is 64 or higher, you're looking at when it's higher than 0. So when is the height above 0? It can't equal 0. If the height equals 0, then the ball is back on the ground. So type in what we have there in y1 and y2. But this time, just change the line that represented the height to be a 0. Okay, and we have to figure out where they cross this time. All right. So I have two intersection points. Which one do I want to find? To figure out how long the ball is in the air for. Yeah? The one on the right. This is the intersection point when the ball is back on the ground. Right there. So we need to figure out when that happens. When does it look like it happens?
5 seconds.
Yeah, it looks like it's at 5 seconds. But we can do second calc, intersect, enter, 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 and it tells you they intersect when x is 5. So how long is the ball in the air for? Less than 5 seconds. At 5 seconds, it hits the ground. So it's in the air like 4.9, repeating. So how long does the ball stay in the air? Less than 5 seconds. Any question on that? Okay, so now, I think we just, when is the ball at least 64 feet off the ground? We already answered that question. That's a repeat. All right, so that's all we really have to do. You just have to find an intersect between two graphs. Okay, let's do another one. Again, we're not doing it as a sign pattern. Okay, so let's try this one. This time they want to know when that quadratic is greater than 0. Okay. So what am I going to put in y1? Yep, put in the expression on the left. 2x squared plus 9x minus 5. Okay. What are we going to put on the y2? 0. We already have it. So that goes in y1. That goes in y2. Okay, let's try zoom 6. We may or may not get a good picture. Yeah, that's okay. We can't see the bottom of it, but we don't need to, because we're looking for where it's above 0. First of all, is the parabola ever above 0? Can you trace the entire time that it's above 0 without lifting your pencil? No. So you have a section over here that's above 0, and you have another section over here that's above 0. You have two separate sections. If we write this as an interval, what symbol do we need between the two? Yep. Yeah, we need the U, that or symbol. So now let's figure out our two intervals. How far to the left is this interval going to go? Yeah?
Infinity.
To the left.
Oh.
Infinity would be negative what?
5.
So it's not going to go any, this is
Oh.
negative 1, 2, 3. So negative 5 is right here. So that part never goes past negative 5? It does. How far to the left is this part going to keep going? Yeah?
Negative infinity.
Yeah, it looks like it's mostly going up, but it is a parabola. It's going to keep getting wider. So this part is going to keep going to the left forever. So any value that you pick for x, like over here, you're going to be way up there on the parabola. Okay, so you're definitely going to be above 0. Now I have to figure out how far to the right I can go. How am I going to figure out where to stop in this interval? We'll call this interval 1. Yeah?
Where it intersects.
Right. Where it intersects right here, that's where you need to stop. If you go past that, then you're going to dip down below the red line, and that's not what they want. They want you above the red line. So let's do second calc intersect. We do have to move our cursor. Good enough. -5. So you can go any number as low as you want, up to -5. Or you can't pick anything in this area. So all these x's are out. Now we have to look at interval 2. How are we going to figure out the lowest x value that's in this interval? Yeah, right. We're going to see where we cross. Looks like it's about 0.5. So we'll do second calc intersect. Yep, we get 0.5, or 1/2. And what's the highest x value that we could pick and still be in section 2 somewhere? Yep, infinity. You can go as high as you want for x. You're just going to be like way up there on your parabola, even higher. So you're always going to stay above the red line if you pick x values to the right. And that's your answer. That describes section 1. This part describes section 2. You just don't want to pick any values between section 1 and 2. If you pick x values in here, you're going to end up down there. That would be less than 0, not more than 0.
Yep. When should you know, or like how should you know when to use that symbol, like the U in between the two?
Anytime you're describing multiple sections, and it could be either or. Yeah. So in this case, you could be here and be above the red line, or you could be here and be above the red line. If you were writing it as an inequality, it would be x is less than -5, or x is greater than 1/2. That's exactly the same thing. This is interval 1. That's interval 2 over there. Yeah.
Is there like an and symbol that we'll have to use?
So there is an and symbol. That's the and symbol. That's called an intersect.
Okay.
I don't think that we're generally going to have to use that to write our intervals in this section. No. Okay. Let's try division 1, and then this will be the last. Or maybe we'll do one more. We'll see. Let's do this one. Whenever you type in a fraction, make sure you use parentheses. So x minus 4, and then 2x minus plus 5. And we've got our line at 0. So we're looking for where this graph is under the red line. Anywhere that it stays under the red line. Okay, let's look at that. Does it look like the graph is ever under the red line?
Yeah.
Yeah, it looks like there is a part that is under. This left part, it doesn't look like it's ever going under the red line. Yeah.
How do you know what you're looking for? Like if you're looking for under the red line or over it?
I'm looking at this symbol.
Okay.
If this is a less than symbol, I want to be under. If it's a
Okay.
greater, I want to be above. And it doesn't have to be a 0. It could be like we did with 64 for the height of the rocket. You could have it up here. But they're just doing 0. Now, if you're not sure if this blue line is ever going to dip down underneath, you can look further to the left. You could set your x min at like -50. But if you keep looking further to the left, you're going to notice it just kind of levels out, and it never actually goes below that red line. Okay, so you can see that by looking. But it does go below the blue line here. All right. Is this section always below the red line, this blue section in the lower right? Not always. It does cross it somewhere right about there. Okay, so we have to figure out, is that exactly 4 or not? So let's see where that is. This is going to be the highest value that we can pick in this section that I'm drawing in green. This is going to be the high, and the low is somewhere in here. We got to figure out where that is. So let's do, this isn't a great window, but it should work. Let's put our cursor over there. So the high value is 4. That's the highest value you can pick in this green section. If you go higher than 4, you will not be under the red line. You'll be above it. You can see it goes above it right there. Okay, so the highest value is 4. Can I include or not include the 4?
You can't.
We can't? Why?
You can't.
You can, yeah, because it does say that you can equal the red line. That's this part right here. It doesn't just say you have to stay under it. You can equal exactly it. And that's where they are exactly equal based on what the calculator told me. Okay, so 4 is the highest. Now we've got to figure out the lowest. The lowest, I mean, you can't go too low. Like if you go -8, you're going to be back above the red line. But if you do -1, you're below. -2, you're below. But then maybe -3, you're back above. How do you think we can figure out how far to the left this green section is going? An idea on that? Well, is there any x value you would not be allowed to plug into the bottom? Two and a half.
Oh, wait, no, -2.
-2.5. Why? What would happen if you plug in -2.5 right there?
0.
You get 0 in the bottom.
Oh, anything.
And then what happens if you have 0 in the bottom of a fraction? No, it doesn't cancel out when you have 0 in the bottom. What happens when you have 0 in the bottom? You what?
Can't divide by 0.
You can't divide by 0. So if there's a number that you could plug in here and it would cause you to divide by 0, that's probably a pretty good hint at how far to the left you can go. Right? You said what number? -2.5? Let's put a dotted line in at -2.5 and just see how close that looks. Okay, oops. Don't move that. Move your, so -2.5. What do you think? Does it look like that is like a boundary that this green solid line is never going to cross? Yeah, and that's what it is. Okay. You can also go to your calculator, go to your table, type in -2.5. What does it say? It says error, because you're trying to divide by 0. Let's pick a number a little bit smaller. What's a number that's just before -2.5?
2.4.
What?
2.4.
-2.4? Are you below the red line at -2.4? Yeah, you're at -32. You're way, way down. Let's see what happens if we go just above 2.5. Let's go to the left of that dotted line. What's a number that's just a little bigger than 2.5? Yeah? -2.6. Now you're up at +33. Are you below the red line now? No, you're up at 33, so you're above it. So negative 2.5 is the number that you use for the lower limit. Right? So generally, if you could divide by 0, that's probably going to be the number that gives you the hint at what to use. Okay? Yeah?
How did you get to negative 2.5?
We set that equal to 0 and solve.
Okay.
Yep. Can you include the negative 2.5? No, because if you include it, you'd be dividing by 0. You can't do that. So that's your answer there. If you pick any x value between negative 2.5 and positive 4, you'll be on that green section, which is underneath the red line. If you pick a value outside of this area, then you're going to be above the blue line, or the blue line's going to be above, or the blue line's going to be above. So you've got to stay between those x values right there. Any question on that? Okay. So I think that's good for that. Okay, so last thing we'll take a look at is actually more on the graphic calculator, which is section 3.1, graphing polynomials. Okay, so first of all, what's a polynomial? Well, polynomials look something like this. That's a quadratic polynomial. That's a linear polynomial. That's a cubic polynomial. Those are all different examples of polynomials. One thing that's very important is that your exponent is a non-negative integer. When I say exponent, I mean these numbers that I'm circling. All the exponents have to be non-negative integers. I'm not saying you can't have a negative number here, like -5. That's fine. That's not an exponent. But the exponents are non-negative integers. So things that are not polynomials would be something like this. You might say, well, there's no negative exponents there. Yeah, there is. When you put a letter in the bottom of a fraction, that's like writing this. Letters in the bottom of a fraction are like having negative exponents. So no letters in the bottom of a fraction. Not for polynomials. That's something else, but that's not what we're doing right now. No square roots either. You might say, well, yeah, there's no non-negative integers there. There is. A square root is the same as raising something to what power? Anybody remember? Yeah?
Is it -2?
No, not -2. Second power is square. This is square rooting. 1/2, yes. If you type in the square root of 9 on your calculator, or you type in 9 to the 1/2 power, you'll get the same answer. So a square root is a power that is a fraction. Fractions are not integers. So these are things that are not allowed for polynomials. The ones in green are good. Ones in red are not. So let's just reword this. So the term, might have to rewrite the whole thing. The term with the highest exponent is the degree of the polynomial. So the term with the highest exponent is the degree of the polynomial. So like this problem right here, what would be the degree of that first one? Yeah, 2. How about the degree of the second one? 1. And the degree of this one? 3. Yep. And we do have special names for some of those. Degree 1, that is called linear. That means if you drew the one that's degree 1, you would get a straight line. It's like y equals mx plus b. What do you call degree 2? Yep.
Exponential.
No, not exponential. We're going to study exponentials, but exponential functions are a different group than polynomials.
Quadratic.
Yep, degree 2 is a quadratic. And what do you call degree 3? What is it? Cubic, yeah. Degree 4 is quartic. But generally, if we get much higher than degree 3 or 4, we just say it's a polynomial of degree 10 or a polynomial of degree 12. Okay, we don't use special names. Those are the most common ones.
What's 7?
I don't know 7 if it would be like, because 7 could be like sept or hept. Those are 2 prefixes. But I've never heard of like sept. Well, yeah, I've never heard of them using the word sept. But quartic and quintic, those would be 4 and 5. I don't know if 6 is hexing. I don't know. The nice thing about polynomials is you never have to worry about the domain. You can plug in any number you want. The domain is all real numbers. Because there's 2 things you're not allowed to do that would mess up your domain. One is to write something with a variable in the bottom. Variables in the bottom are not allowed in polynomials. So that would be an issue, but it's not allowed. So we don't have to worry about that. The other problem is if you try to take the square root of a negative number. But square roots are not allowed in polynomials either. So the 2 things that are a problem with domain are not allowed in these kinds of functions. So you can take any number you want and square it. You can take any number you want and multiply it by 3. You'll never have an issue with anything in the domain. But the range depends. Okay, so to figure out the range, we graph it on the calculator. So here's some examples of cubics. This number tells you, well, if you subtract 1 from the degree, it tells you how many times it could turn. So a degree 3 could turn, doesn't have to turn, could turn twice. And this is what generally degree 3 polynomials always look like, something kind of like those. Sometimes they go up and then they start to turn, but they never do. And then sometimes they actually do a full turn and another full turn. But a cubic can't take 1 turn. That's a problem. If something just turns 1 time, up to down, that's not a cubic. That's a problem. Yeah.
I just had a question. With like you said, like subtracting 1 from what the degree can tell you how many times it turns.
It can tell you how many times it could turn.
Is that what like all the functions?
Yes. Yep. So this is a 4th degree. It's got even more terms in it. It's got a 4th degree, 3rd, 2nd, 1st, all the way down to the constant. And a 4th degree polynomial can turn 3 times. Could turn 3 times. 1, 2, 3. Fifth degree polynomial could turn 4 times. So this is what a 5th could look like. That's 5th. 1, 2, 3, 4 turns. I don't want to keep that one there because that's not a 4th. That's what it could look like. So this is a polynomial. They want to know the domain and the range. What's the domain of that polynomial? Yep.
All real numbers.
All real numbers. Never have to think about the domain. Because the two things that would give you an issue are not allowed to happen in polynomials. So you can do all reals, or if you enjoy set notation, there's your set notation for all reals. And now the range, well, we have to graph it. So x to the fourth plus 5x cubed plus 2x squared minus 8x. And want to clear the problem so you get to practice typing it in again. Plus 1. All right, so let's do zoom 6. In range, we're looking at how high and low it goes. Okay, is that a good window? Not quite. We gotta go a little bit lower. So on your y min, let's do like negative 25. Okay, that's a good one. This graph does go in one direction forever. Never stops in one of them. Does this particular graph go up forever or down forever? Yeah, up. It does go up forever. So when we describe the range, what is the highest value that you will ever hit on the y-axis?
Infinity.
Infinity. Can we include it?
No.
No. The lowest value is right there. That's the lowest that this graph ever goes down. So we're going to calculate something. What do you think we're going to calculate here? Minimum. So option 3. Pick a point to the left, right, and do your guess. The minimum, or the lowest that it ever goes, is negative 11.95. That's the lowest. Remember, we're looking at range. Range always means the y. Negative 11.95. And we do reach that. I know we reach it because I just looked at it on the calculator. It says I reach it right here, negative 11.95, if I round. So that's how you find your domain and range. Any questions on that one? So 5th degree just means it can turn one more time, that's all. So in that last problem, we calculated a minimum. Anywhere that a graph turns, changes direction, you either get a local minimum or a local maximum. What I'm saying here is, when I say the word local, I'm not saying that this graph, that's the lowest point this graph ever hits. No, it goes lower over here. I'm just saying that this value is lower than everything around it. Okay? It's like a valley. Doesn't mean it doesn't go lower somewhere else. Same thing with here. I'm not saying this is the highest value that it ever hits. I'm just saying it's the highest value in that area. So local maximum and local minimum. A local maximum is a point on the graph that's higher than everything around it in a section. And a local minimum is a point that is lower than everything around it over a certain section. Now, sometimes a minimum or maximum might be what we call global. That's a global maximum right there. Global means this is the highest maximum value you ever hit, period. The graph does not go higher than that spot right there, anywhere. Okay? versus this, that's a local maximum. It's not the highest, but it is in that area. Okay. And together, local minimums and maximums, those are called extrema. So if you see directions that say find all local extrema, that basically means to find all the minimums and the maximums. And that's something we do on the calculator. So it's a heavy calculator day. A lot of stuff on the calculator. Okay, so let's try finding the minimum of that graph and where it occurs. So the calculator will tell us both. You just have to know how to interpret the two numbers the calculator is going to give you. Well, first step is to type it in. X cubed minus 4x. Let's do zoom 6. First of all, does that graph have a local minimum? Yeah, it has. It's in quadrant 4. So let's find the minimum. And then answer both parts of the question. What the minimum is and where it occurs. Okay, so the calculator gives you two numbers. It gives you an x and it gives you a y. The y is the minimum. So this is the minimum. This is where it occurs. Okay, so that's the difference. This is what the minimum is. This is where the minimum occurs. So to answer that question, find the local minimum. You would say the local min is, and then tell me how far down it goes. It goes down to about negative 3.08. And then what the minimum is the x value. Okay? It occurs at 1.15. Mr. Hager? Hi. Yes. And this occurs when x is 1.15. So that's how you would answer that question. You tell me what the minimum is, and then you tell me where it occurs, or when it occurs. And it's the same deal for the maximum. Okay? Same deal. So any question on how you find a local minimum or a local maximum? It's all on the calculator. Any question how you do that one? It's the same thing. Okay, and the last thing is once we know the local minimums and maximums, we can describe where the function is increasing and decreasing. Increasing for this particular problem would be here and here. Decreasing would be there. Increasing is anywhere that you have a positive slope. Decreasing is anywhere where there would be a negative slope. So let's look at this one. Where is that graph increasing? We don't have actual numbers. We just have letters, but that's fine. You would get these by doing the minimums and maximums. Yep.
From B to C.
Yep. So it's increasing from B to C. You don't include the B or the C. Because imagine you were standing at point C. What kind of slope would it feel like if you were standing exactly right there? Yep. flat. You wouldn't be feeling like you're going uphill. You wouldn't feel like you're going downhill. You're not going up or down. You're flat. Okay, so we don't include the C. So yeah, it's increasing from B to C. Where is it decreasing? Yeah.
A to B and C to D.
Yep. And A you can definitely include, because if you were standing at A, you'd feel like you're going to fall. So A to B, don't include B because it's flat at B. And what was the other one you said?
C to D.
Yep, C, don't include it because it's flat. D you can include because if you were standing at D, you'd feel like you're going to fall. Okay. So what happens as you go from increasing to decreasing? You get a special thing in your graph. As you go from increasing to decreasing. It curves, and what happens? More specific in that curve. As you go from increasing to decreasing, you create something in your picture. Yeah?
Is it a parabola?
Well, this goes from increasing to decreasing, but we don't have a parabola in this picture. That's a cubic. Or could be a cubic. Something we just talked about. Yeah? Yeah, you get a maximum. Anytime you go from an increasing to a decreasing function, you always get a maximum. How about as you go from decreasing to increasing? Yep, you get a minimum. Yep. Anytime you go from going down and then you switch to going up, you get a minimum. Okay, so let's look at that graph we already have. Let's put that back here. And I want you to tell me where this one is increasing and decreasing. I just need to find the maximum so you can do that. Okay. Now you've got everything you need to figure out where it's increasing and decreasing. When you describe the increasing and decreasing, you use the x value. How many different sections do we have to describe on this graph? How many? Yep, 3. This is 1, this one is 2, and this one is 3. What's happening in section 1? Increasing or decreasing? Increasing. And what's the lowest x value in section 1? Yep. Lowest x. Yeah. If you pick anything going to negative infinity, you'll be on section 1. And how high can you pick of a value and still be in the first section? We need to stop right there. Yep.
Negative 1?
Not quite negative 1. What does it say?
Oh. Negative 1.15.
Right, you've got to stop at negative 1.15. So that's how you describe increasing and decreasing. Okay, so that will definitely be on the test, so you've got to know how to find the maximums and minimums. Any question on that? Okay, so let me take a look at so the first page, that's what we did on the graphs where you're looking at the inequalities above and below 0. And the second page, that's the domain, the range, local minimums, local maximums.